Before we go on to Newton's second law, we need to understand what is the meaning of momentum. Here in the picture we can see a truck and a car. If both of them move with the same speed, could you tell me which one will create greater impact? Both are moving with the same speed. And you'll definitely agree that it is the truck who will create a greater impact than the car. When I say greater impact, I mean if the truck were to hit collide with some other vehicle or hit a wall, it is the truck that would create a greater impact. And why would the truck create a greater impact? Because the truck has more mass. So we can say the magnitude of impact of a moving body depends on its mass. Greater the mass of the body, greater is its impact. In these two pictures, I can see a bullet being fired and here a ball being thrown. And if I ask you the same question, which of them will have a greater impact? And you'll definitely say it is a bullet that will have the greater impact. Now, although the bullet has less mass, why is it creating a greater impact than the ball? Because the bullet is moving with a greater speed. The bullet moves with a much greater speed, hence creates more impact. Although, remember, the ball has got more mass, but it's a bullet that is creating more impact because it has got more speed. Thus, we see the impact created by an object depends on two factors, depends on the mass of the object and the velocity of the object. And the product of mass and velocity is called momentum. So now we can go ahead and define momentum. Momentum is the product of mass and velocity is called momentum. Now we can say momentum equal to mass of body into its velocity. So what could be the unit of momentum? The unit of mass is kg and that of velocity is meter per second. So unit of momentum will be kg meter per second, or you could write it kg meter second raised to -1. Another point to remember is momentum is a vector quantity. It has direction and magnitude. Here's a picture of a place hit by a storm. And why is storm able to produce so much damage? Because storm is made up of particles, and these particles move at a very high speed. They are small particles. They aren't large. They're small particles which are moving with a high speed of as much as 100 km per hour. And because they have this high velocity, they are able to bring about so much damage. Because of its high velocity, they have large momentum and they can bring about a lot of damage. There's another thing we've been always told not to move at high speed, and the reason is when we are moving at high speed, like in this case, the impact is much more, and hence the damage caused by the car is more. When a car is at high speed, it has got high momentum. So a car at high speed has high momentum. And if it were to collide, there would be a great impact and it would be very dangerous for the driver. What is the momentum of a man of mass 75 kgs when he walks with a uniform velocity of 2 meters per second? So the mass equal to 75 kg and velocity equal to 2 meter per second. And we know the formula for momentum. Momentum is a product of mass and velocity. So we have momentum equal to 75 into 2, that is 150 kg meter per second. Calculate the momentum of a toy car of mass 200 grams moving with a speed of 5 meters per second. So here the mass, so the mass in this case is 200 gram and the velocity is 5 meter per second. Now gram is not an SI unit. We need to change in SI unit. We need to change to kg. That is 200 over 1000. Divide by 1000 to change to kg. Now the formula for momentum is mass into velocity. So put momentum as P. Mass is 200. Mass 200 over 1000. Velocity is 5 meter per second. So this becomes 1000 over 1000, which is 1 kg meter per second. What is the momentum of a car of mass 1500 kgs when its speed increases from 36 km per hour to 72 km per hour? So in this case, the mass m is 1500 kg. Then we have the initial velocity. 36 is the initial velocity. We call it as u. And in this case, the initial velocity is 36 km per hour. And then we have the final velocity, which we call v, and that is 72 km per hour. However, in this case, this 36 km per hour has to be changed into meter per second. So you do 36 into 5 by 18 to change it to meters per second. And this now works out as 10 meter per second. So the initial velocity is 10 meter per second. Similarly, for the final velocity, it is 72 km per hour. We need to change meter per second. We multiply by 5 by 18 v. So that will now become 20 meter per second. That is the v. So again, we have mass, which was 1500 kg. We have initial velocity, which we call u, and that was 10 meter per second. Final velocity, we call v, that was 20 meter per second. Here we need to know the change in momentum, and the change in momentum is final momentum minus initial momentum. So to find initial momentum, momentum is mass into velocity, so initial momentum will be mass into initial velocity. That is m into u. M is 1500 and we know the initial velocity is 10. So initial momentum, we'll call it as P1 is 15000 kg meter per second. Now to find the final momentum. Final momentum again will be mass into final velocity. So momentum is final P2, mass is 1500, final velocity we saw is 20. So this will be kg meter per second. Change in momentum is final momentum P2 minus the initial momentum P1, which is equal to, the final momentum was 30,000 minus initial, which was 15,000. So the answer is 15,000 kg meter per second. Calculate the change in momentum of a body weighing 5 kgs when this velocity decreases from 20 meter per second to 0.20 meter per second. So here's mass which is m equal to 5 kg. 20 meter is the initial velocity, we call it u, and 0.20 is final velocity, we call it v. So initial velocity u is 20 meter per second, and the final velocity is v, which is 0.20 meter per second. Now if you see in this body, the speed is decreasing. From 20 meter per second, the speed is dropping to 0.20 meter per second. So there will be a decrease in momentum. The momentum will decrease because the speed has decreased. So to calculate first the initial momentum, and that will be mass into initial velocity, that is u. So mass is 5, u is 20, here is 20. So that would be 100 kg meter per second. Now for final momentum, which is P2, with mass into final velocity. This is our final velocity. So mass is 5, final velocity is 0.20. That will be 1 kg meter per second. Now to find change in momentum will be final momentum minus initial momentum. Now the final momentum we saw is 1, initial momentum was 100, so here it will become minus 99 kg meter per second. Why did we get negative? Because there was a decrease in momentum. And why did the momentum decrease? Because there was a decrease in speed. The body was slowing down.